And I guess I have space right here. Oh, fun.
Is this for today?
Yes. So let's start with this. If I give you two angles A and B, what's the cosine of A plus B? Cosine A, cosine B, minus sine A, sine B. What happens if instead of adding I subtract?
It's just plus sine A and B.
That minus changes to a plus, as you might expect. What about the sine of A plus B? What is that the same as?
Sine A cosine B plus cosine A sine B.
Yeah. Product of the sine and the cosine of the two different angles plus the product of the sine and the cosine of the two different angles in the opposite order. And again, if you change that to a minus, this becomes a minus. And we didn't hit much on angle addition for tangent, but we stated it. What is the angle addition formula for tangent?
Tangent A plus tangent B over 1 minus tangent A times B.
Which is handy. Now, we did hit this a little bit last time. If you have a formula that says what happens when you add angles, well, 2 times an angle is just that angle plus itself. So we should be able to get an angle addition formula, a double angle formula, because 2 times an angle is just that angle added to itself. So, I think there's enough space right here. So let's walk it out, and I'll box the simplified version of these formulas in various colors. So, since cosine of 2 theta is the same as cosine theta plus theta, we can use angle addition. Cosine of theta plus theta will be cosine theta minus sine theta, also known as the square of the cosine of theta minus the square of the sine of theta. So there's one version of the double angle formula for cosine. What do you think? Could we rewrite that so that it's a only involved cosine?
Yeah.
Yeah, because what is sine squared the same as?
1 minus cosine squared.
1 minus cosine squared. So we could replace that sine squared with 1 minus cosine squared. So that's the same thing as cosine squared theta minus 1 minus cosine squared theta. And those parentheses are kind of important, right? You need to subtract all of what sine squared is. And so you can simplify that sum. That's the same thing as cosine squared plus 1, minus 1, plus cosine squared of theta. And then you can simplify, right? I see cosine squared theta plus another cosine squared theta. There's a 2 cosine squared theta minus 1. There is a second version of the double angle formula for cosine. Maybe that one seems a little bit more friendly because it only involves cosines. And we could just as well rewrite that so it only involves sines, right? It would be like the same sort of walk again. Is it out of focus or anything? Is it okay? Okay. Okay. So, I won't go through the walk, but let's rewrite that. If you rewrote that by re-expressing that cosine as a sine, I guess you would get 1 minus sine squared minus another sine squared. So 1 minus 2 times the square of the sine. So there are 30 different double angle formulas for cosine. Depending on what situation you're in, one of those will be more useful than the others. If, say, you're in a situation where you know exactly what sine and cosine both are, then the first one might be the easiest to use. If you're in a situation where you know what the sine of theta is, well, then you already know what the cosine of 2 theta is because you have that last double angle formula. Sine 2 theta, we can figure out a formula for that by doing the same thing. That should be the same thing as the sine of theta plus theta. So that'll be sine theta cosine theta plus sine theta cosine theta. And what does that simplify to?
Two times cosine times 2 parentheses cosine sine, right?
Yeah, multiplication is associative though, so those parentheses don't matter. All right, 2 times sine times cosine, and it doesn't matter what order you multiply in either. Right? Everyone feel pretty good so far? There's also a double angle formula for tangent. It'll give us, let's switch colors, it's too close. Tangent theta plus tangent theta all over 1 minus tangent theta tangent theta. So that's 2 tangent theta divided by 1 minus the square of the tangent of theta. So if you know what the tangent of an angle is, yeah.
So, right above that, are you supposed to put parentheses like around the sine and cosine next to the 2? Like, is the 2 multiplied by cosine as well?
Ah, so let's remember how multiplication happens. So multiplication is associative. So you could put parentheses here, it wouldn't be wrong, but it wouldn't change anything.
Okay.
Right.
Could just as easily be sine 2 cosine, right?
Yeah. Right, so if I wrote down 2 times 3 times 5, that's the same thing as 2 times 3 times 5. So maybe just for emphasis, that's definitely not the same as 2 times 3 times 2 times 5. That's definitely not the same, right? You don't distribute multiplication over multiplication. I guess in practice, you can put the parentheses there or not. They don't really matter in for this because multiplication is associated. So let's just go through some computation. Let's suppose I give you an angle, theta. I tell you that the sine of that angle is 3/5. That angle theta lives between pi over 2 and pi. And then I ask you to compute all of the trig functions at this angle, at the double of this angle. So let's try to do that. Maybe I'll start with cosine of 2 theta. That one is the easiest. So according to the double angle formula for cosine, if I know both cosine and sine, then I can compute the cosine of 2 theta. If I know just cosine, I can compute the cosine of 2 theta. If I know just sine, then I can compute the cosine of 2 theta. Do I know at least one of those things? Yeah, so which of those 3 double angle formulas for cosine should I use? Well, I guess the options are the one that needs sine and cosine, the one that just needs cosine, or the one that just needs sine.
The one that just needs sine.
The one that just needs sine, because we have sine. We're about to compute the other thing in a moment, but may as well do everything we can straight away. So apparently the cosine of 2 theta is the same thing as 1 minus sine squared theta. And what's sine theta? 3/5. So it'll be 1 minus the square of 3/5, also known as 1 minus 9 over 25. So I guess I should also rewrite the 1 as 25.
Is it 2 sine?
Yes, it is definitely 2. Thank you for saving me. So then you compute the sine squared, you get 9 over 25, then you multiply it by 2, you get 18 over 25. Happy enough? And now we just have to simplify. I guess that's questions so far? Okay. What's 25 minus 18? 7. And they have the same denominator now, so I get 7/25.
Isn't that 3/5? You would multiply it by 5, so wouldn't it be 15/25?
Let's do it more slowly on the ball. So we're going to compute the cosine of 2 theta. So there's the thing that we need to compute.
Okay. That makes sense.
Do people want me to go through it more slowly right now? Is there a demand? Okay, then I will go slowly. So we just need to compute this. I guess the first thing to do is to square 3/5. And you square a fraction by squaring the numerator and squaring the denominator. And then, well, how do you multiply 2 by a fraction? Well, you just multiply the 2 into the numerator. Now I need to subtract some fractions, but I know how to subtract fractions. I just need a common denominator. And then they have the same denominator, so it's easy to subtract. People feel okay about that? What is the double angle formula for sine?
2 sine, cosine.
2 times sine times cosine. And so there's no putting it off. In order to use that formula, I need to know what cosine is equal to. So, what is cosine equal to?
Couldn't you just take what we just found and divide it by 2? Never mind.
No, so that would be using cosine of 2 theta where you need cosine of theta.
Okay.
If you know that the sine is 3/5, well, on the one hand, like, how many people just remember when sine is 3/5, cosine is always,
4/5.
4/5, or negative 4/5, right? There could be a plus or minus. And let's see, for angles that are between pi over 2 and pi, what quadrant does that live in? Quadrant 2. So plus or minus?
Minus.
People want to go through the walk slowly of finding cosine given sine? Another example of that? Okay, I'll go through it. So, let's do it. So, what is the important formula which relates sine and cosine? The Pythagorean identity. You always know that sine squared plus cosine squared is 1. So you always know that sine squared of theta, which you know right now, plus the cosine squared of theta, which you would like to know right now, add those together, you will always get 1. Therefore, 3/5 squared plus cosine squared, I'll rewrite it as c so I can be a little bit lazier, is equal to 1. And then you just need to solve that for c. So I guess how do you do that? 3/5 squared is 9/25, so you subtract that to the other side. You'll get c equals 25 c squared over 25 minus 9 over 25. Right, subtract the 9/25 to the other side, because 9/25 is 3/5 squared. 25 minus 9 is 16 over 25. So c squared, so c itself is plus or minus the square root of 16 over 25. It has to be negative because this angle is in quadrant 2. And the square root of 9 is, nope, the square root of 16 is 4, the square root of 25 is 5. People pretty happy? But now we know sine and we know cosine, so we know everything we need to compute the sine of 2 theta. It's 2 times the sine of theta, and what is the sine of theta? 3/5 times what is the cosine of theta? Negative 4/5. We just computed it. And so now we just need to do that multiplication. And it's just multiplication of fractions. That's the easy thing to do. You multiply the denominators to get 25, and you multiply the numerators to get 2 times 3 is 6 times 4 is 24, but it's negative. People feel pretty okay? And now let's see, let's compute tangent of 2 theta. Yeah.
How did you decide that cosine was negative?
How did I decide cosine was negative? So, here's the angle information I'm given. The angle theta is between pi over 2 and pi. So, in the unit circle, right, there's pi over 2, there's pi. So this angle lies somewhere in that quadrant. Oh no! There's an angle of pi over 2. There's an angle of pi. This angle is somewhere between them. So in that range, cosine is negative. Nice. Let's try to compute tangent. And I see 2 ways to proceed. On the one hand, we have a double angle formula for tangent that we could use. That would require us to know what tangent of theta is, which we could. On the other hand, do we know what the sine of 2 theta is? Do we know what the cosine of 2 theta is? So you can just take the ratio. We can compute this as green. Sine of 2 theta, which we've computed, divided by the cosine of 2 theta. And what will you get? You'll get negative 24 over 25, because that's the sine of 2 theta, divided by 7 over 25. But if you divide the numerator by 25 and divide the denominator by 25, that doesn't change the fraction, so you could cancel those. Or maybe this is the most explicit thing to do. That's the same thing as negative 24 over 25 times 25 over 7. Right? How do you divide by a fraction? You multiply by the reciprocal. Now you definitely see the 25s cancel, resulting in negative 24 over 7. How do people feel about that? Is that a pretty straightforward application? Yeah. As soon as you know angle addition, you can get a double angle formula.
So tangent of 2 theta is the same as sine squared theta over cosine squared theta, or it's cosine. Oh, okay.
That's a 2.
Okay, okay.
The 2 is supposed to be low, not high.
Okay. I was confused for a second.
Fair enough. Right, I guess that 2 looked slightly elevated. Everyone feel pretty good? So now we know what happens when you multiply an angle by 2. So we should be able to undo that formula and decide what happens when you divide an angle by 2. Let's try to get a half angle formula. And, well, here's how we'll do it. Instead of trying to express cosine of, so the goal is going to be expressing cosine of theta over 2 in terms of cosine of theta. In order to do that, let's go the opposite way first. Let's try to express the cosine of theta in terms of the cosine of theta over 2. And that may seem like a silly thing to do, but you can, right? Cosine of theta is the same as the cosine of 2 times theta over 2. And so now, maybe I'll put that in an extra set of green parentheses. Can I apply the double angle formula to that?
You could?
I could, and I think I'll even use the one that leaves me in the setting of cosine. So let's use the double angle formula to express that. So the cosine of 2 times a thing in green, which maybe I'll even box up, should be the same thing as 2 times cosine squared of whatever thing in green I see, minus 1. And, I mean, that was a silly thing to do, right? So what is the thing in green? Theta over 2. So that means that the cosine of theta is the same thing as 2 times the cosine squared of theta over 2 minus 1. Could I solve that for cosine of theta over 2? Of course I could, right? I guess I would add 1 to the other side to get, let's do it down here. Cosine of theta plus 1 is equal to 2 times the cosine squared of theta. I would then divide by 2. getting cosine of theta plus 1 over 2 is equal to cosine squared of theta. And now what would you do to find cosine of theta? Take a square root. So apparently then, theta over 2, Chris. The cosine of theta over 2 is the same thing as the square root of the cosine of theta plus 1 all over 2. But have I forgotten anything? Plus or minus. Whenever you want to do a square by square rooting, you lose information. So that gives me the half-angle formula for cosine. The cosine of theta over 2 is plus or minus the square root of the cosine of theta plus 1 all over 2. How many people find it frustrating that that formula seems to be ambiguous? If you know the cosine of theta, apparently the cosine of theta over 2 might be two different things. I mean, it is annoying, right? That means that even if you know the cosine of theta, you don't really know what the cosine of theta over 2 is. You have to decide if it's positive or negative independently. What's the usual trick for deciding if a cosine is positive or negative? What do you think about?
Quadrants.
Think about what quadrant is. So you need to worry about quadrants by doing something else other than just looking at a formula. And let's see that in practice. Let's try to compute the cosine of pi over 8, and we'll also do the cosine of 9 pi over 8. And here's how we'll think about it. We'll try to realize that as half of an angle that we know, and then use the half-angle identity. Is pi over 8 half of an angle that we know? Yeah. Pi over 8 is half of pi over 4. So let's use the half-angle identity, which maybe I'll put on the board just so that it stays visible. Is this not a good place to hide, or is it invisible? Okay. Let's try to do it. So, how many people remember a while ago when we just kind of computed cosine of pi over 8? Well, no, wrote down what cosine of pi over 8 was without walk. Maybe you don't remember what it was, but now let's do the walk to see what it has to be. So, I can now use the half-angle identity. I'll plug in that pi over 4 as theta in the half-angle formula. That pi over 4 will be theta. So the half-angle formula now says the cosine of pi over 4 over 2 should be plus or minus the square root of 1 plus the cosine of whatever that angle in green is divided by 2. And what is that angle in green? That angle in green is pi over 4. So now let's just evaluate. Do we know what the cosine of pi over 4 is?
Root 2 over 2.
Square root 2 over 2. So I'll get plus or minus. Oh, maybe we should also take a moment and deal with the plus or minus so I can stop writing it. 1 plus the square root of 2 over 2, parentheses, parentheses, all over 2. What quadrant is pi over 8 in? Quadrant 1, right? It's a positive angle that's really, really, really small. That's too many willies. It's a small positive angle. So this angle pi over 8 is in quadrant 1. So whatever cosine of pi over 8 is, it has to be positive. So I know that I have to take the positive choice. And now let's just simplify. I see 1 plus a fraction in the numerator. So in order to add those fractions, let's get a common denominator. So it's plus the square root of 2 over 2 plus square root 2 over 2 all over 2, where big square root, everything's under the square root. Everyone following so far? And now let's just go through the motions. I have the common denominator to deal with. So it's the square root of 2 plus the square root of 2. But then I divide by 2, and then I divide by 2 again. Let's see, if you divide by 2 and then you divide by 2 again, that's the same thing as dividing by... Yeah, but just like say it instead of flashing the hand. 4, right? If you divide by 2 and divide by 2, you've quartered. So you get the square root of 2 plus the square root of 2 all over 4. That 4 is still under the square root. Do you see a perfect square under that square root? Yeah. So you get the square root of 2 plus the square root of 2. That's a plus sign. All over 2. Which maybe you remember is the formula we got before because it has lots of 2's in it. People feel okay? Let's try to do the same thing, but let's try to compute the cosine of 9 pi over 8 by going through the same motions. So 9 pi over 8 is the same thing as 9 pi over 4 all over 2. So we should get plus or minus the square root of 1 plus the cosine of 9 pi over 4 all over 2. So right, that 9 pi over 4 is exactly the thing in that top of the thing divided by 2. And now let's just try to, let's deal with the plus or minus sign first so we can stop writing it. An angle of 9 pi over 8, what quadrant is that within? Right here, quadrant 3? Right here, any other quadrants? Yeah. But it was said quietly, so I'm going to draw the picture. Right, to decide what quadrant it's in, was out of pi over 8. So let's see. That would be pi over 2, which would be 4 pi over 8. Not big enough. There's 8 pi over 8. It looks like I just need to go a little bit farther. There's 9 pi over 8. Yeah, that's quadrant 3. In quadrant 3, is cosine positive or negative? Negative. Negative. So it's in quadrant 3, so I'll take the negative choice. And now let's evaluate. By glancing at your units, Arkell, what's the cosine of 9 pi over 4?
Negative root 2 over 2, probably.
No.
No? Okay.
Let's even just count it out. It's clearly going to be a pi over 4 thing, so let's just count out pi's over 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. So cosine of 9 pi over 4 is? That's got to be positive, right? Because it's that point. Right, you've gone around 2 pi, and then you've got another pi over 4.
So we're at 2 over 2.
So positive root 2 over 2. So there's the visual way to make that computation. So this is negative the square root of 1 plus the square root of 2 over 2 all over 2. And those parentheses don't matter. The order of operations will take care of them, but I'll just put the parentheses in for emphasis. Is that like exactly the same thing as you just computed? But with a negative sign up front? So without doing any more work, what is that going to be? Yeah, it'll be exactly this, but negative. Cool. Everyone feel okay? So let's make, let's see, so by looking at your units, Arkell, what's the cosine of pi over 6?
Root 3 over 2.
Root 3 over 2. So we already know that the cosine of pi over 6 must be root 3 over 2. In order to check that this is like consistent seeming, well, I know that that's half of an angle that I know. What's the cosine of pi over 3? 1/2. So since I know the cosine of pi over 3, I should be able to figure out the cosine of pi over 3 over 2 using half angles. Let's see if it agrees with what we already know.
Can you scoop the figure up a bit?
Yeah.
Maybe.
Let's try to compute the cosine of pi over 3 over 2. Using this technique, we already know the answer we have to get if this is actually a reasonable thing. We have to get the square root of 3 over 2. Now let's see if we actually do. So according to this formula, we should get plus or minus the square root of 1 plus the cosine of pi over 3 all over 2. And let's just see if it works out. Plus or minus false. What quadrant is pi over 6 in?
1.
1. So that would be the plus option. And I guess we already knew what the answer had to be, so it couldn't possibly have been the negative, because we already knew what the answer had to be. What's the cosine of pi over 3?
1/2.
1/2. So we should get positive the square root of 1 plus 1/2 all over 2 with all of that under the square roots. And let's simplify. 1 plus 1/2, that's 3 halves. 1/2 is the same thing as 3 halves. So I see the square root of 3 over 2 in the numerator divided by 2, also known as the square root of 3 over 4. Is there a perfect square under that square root that we could pull out? The 4. 4 is 2 squared, so I'll end up with root 3 over 2. So last time we also computed, well, last lecture, Tuesday I guess, we computed the cosine and sine of pi over 12 by using angle addition formulas. Let's see if we can get the cosine of pi over 12 by using half angles. Because is pi over 12 half of an angle that you know? Yeah, of course it is. It's pi over 6 over 2. So if you want to compute the cosine of pi over 12, you will compute the cosine of pi over 6 over 2, because pi over 6 over 2 is pi over 12. And now we have a formula we can use. We know that this should be this plus or minus the square root of 1 plus the cosine of pi over 6, all that divided by 2. Do we know what the cosine of pi over 6 is?
Root 3 over 2.
Root 3 over 2. So we'll see plus or minus big square root 1 plus root 3 over 2 over 2. And now it's just like a simplification game, right? So go ahead and simplify. Tell me what you got. And once you have a numerical answer, I guess you can check it by asking our computer to also compute that, maybe getting some decimal approximations. You can compare by looking at those around you. Once you're confident in an answer, tell me what you got.
So it should be root 2 plus root 3 all over 2.
That's what the machine said?
That's what I said.
Okay. Okay, so like this, root 2 plus root 3 all over 2. Okay.
Yeah.
Awesome. Cool. People feel pretty good about that? Yeah. So there's another way to compute angles divided by 12, because they're half of an angle you know. And let's see, maybe Well, that's already been done. Oh, there's been some like silly copy paste error. Redundancy, redundancy, redundancy. So we now have a half-angle formula for sine. Let's get a note we have a half-angle formula for cosine. We would like a half-angle formula for sine. If you know cosine, how can you find sine? By doing an identity? Let's do that. Let's try to get a formula for the sine of theta over 2 by using that. So apparently we should get the sine squared of theta over 2 plus the cosine squared. Let's rewrite it this way. The cosine of theta over 2 squared, that should always be equal to 1. But we have a formula for the cosine of theta over 2. Let's use it. So by using the half-angle formula for cosine, we'll see that the sine squared of theta over 2 plus the square root of 1 plus the cosine of theta all over 2, take that and square it, should be equal to 1. So how many people are upset that I left the plus or minus out of the formula?
It's squared, so it doesn't matter.
Squared, so it doesn't matter. It's an oversight on my part, but I mean, I guess we can put it back. But it doesn't matter. If it's negative, right, the square will make it positive. So go ahead and square it, and in fact, you notice one other thing. It'll cancel out the square root. That's nice. So we get sine squared theta is equal to, plus 1 plus the cosine of theta all over 2 is equal to 1. Hey, look, I just need to subtract that stuff to the other side. So let's subtract that stuff to the other side. And in fact, it looks like it has a denominator of 2, so I'll rewrite 1 as 2 over 2 to make the subtraction easier. So I'll see that sine squared of theta is equal to 2 over 2 minus 1 plus the cosine of theta all over 2. Any questions?
When you square it, wouldn't the 2 become a 4?
What did I square?
Like the 1 plus cosine of theta, when you square that.
The 2's under a square root. Right, it's a big square root.
Okay, okay.
Yeah.
Sine squared of pi of theta over 2, or is it just? Okay.
Yep. Thank you. Which it better be, because I want the formula for the sine of theta over 2. So let's simplify a little bit. I see 2, I have a common denominator of 2, so subtraction is easy. It'll be 2 minus 1, and then I'll distribute the minus over to that also. Maybe I'll do that all at once. Distribute the minus sign throughout. So I'll get 2 minus 1 minus the cosine of theta all over 2. So sine squared of theta is 2 minus 1 is 1 minus the cosine of theta all over 2. And now I have a formula that tells me what sine squared of theta over 2 is. So what's the sine of theta over 2? Oh, if you know what sine squared is, how do you figure out what sine is? What undoes squaring? Square root. So I just need to take the square root of both sides. But it doesn't really undo it. It undoes it up to a plus or minus sign. So we get sine of theta over 2 is plus or minus the square root of 1 minus the cosine of theta all over 2. Rewriting on the front page, plus or minus the square root of 1 minus the cosine of theta all over 2. And I mean, I guess we have a formula. Let's use the formula. Let's compute the sine of pi over 8. See if it is what we remember it being. So apparently the sine of pi over 8, that's the same thing as sine of pi over 4 over 2. So by the half-angle identity, this should be plus or minus the square root of 1 minus the cosine of pi over 4 all over 2. People feel okay? Haven't done anything silly yet? So let's use this. What's the cosine of pi over 4? Root 2 over 2. So I'll see plus or minus the square root of, there will be a minus root 2 over 2, and I see that, hey look, I'm going to need like that one to be 2 over 2 to subtract fractions. People feel okay about that? And so now let's just subtract fractions. They have the same denominator because they have been arranged to have the same denominator. I'll get plus or minus the square root of 2 minus root 2. And then it looks like I need to divide by 2 and then divide by 2 again. So I get plus or minus the square root of 2 minus root 2 over 4. That 4 is a perfect square, so I can divide the whole thing by 2. And now let's do all the plus or minus. Maybe we should have done that first. What quadrant does pi over 8 live in? Quadrant 1. So plus or minus. Which, right, you could have done at the very beginning. You would have had to write fewer plus or minuses then. People feel okay about that? Nice. So, yeah, I think we have time to do this. So, let's try to compute all of the trig functions at, I don't know, 5 pi over 8. Why not? By doing this exact same thing. So apparently to compute trig functions at pi over 8, I'll need cosine of pi over 4. What's the cosine of pi? What's the cosine of 5 pi over 4? Plus or minus? Negative root 2 over 2. So it'll be 1, 2, 3, 4, 5. So quadrant 3, that'll be negative. And I don't care what sign is. So using that, so I think here is what I will do. I will go through and compute cosine. Those of you who feel strong and independent should compute sine. And then we'll come together. Once we know sine and cosine, will we be able to compute tangent? Yeah, sure will. So let's do that. Let's compute cosine. So the cosine of 5 pi over 8 should be plus or minus the square root of 1 plus, so cosine, right, there's a plus there. I should write the 1 sign also. So that's what you get. But we know what the cosine of 5 pi over 4 is. The cosine of 5 pi over 4 is negative root 2 over 2. So we'll get, let's deal with the plus or minus also. 5 pi over 8, what quadrant will that live in? Let's count it out. So there's 1 8, 2 8s, 4 4, 3 8s, 4 8s, 5 8s. So which quadrant? So positive or negative? Or cosine? Negative. For those of you who are doing sine, should sine be plus or minus? Plus. So now we have everything we need. So we have negative the square root, big square root, 1 plus negative root 2 over 2. So 1 minus root 2 over 2, all over 2. How many people just already see how that's going to simplify because it's the same thing as we computed on the previous page? Yeah. it'll break down to negative, because of this negative, the square root of 2 minus square root of 2 all over 2, where this negative sign is because of that negative sign. That was fast, but was that okay? And now, how about sine? What did people get for sine?
Positive root 2 plus root 2 all over 2.
Cool. And so now we'll black box that. Now that we know sine and we know cosine, how can we compute tangent?
Divide sine by cosine.
Divide sine by cosine. So the tangent of 5 pi over 8 will be sine. And give myself enough space. 2 plus the square root of 2 square rooted over 2, divided by negative the square root of 2 minus square root of 2 all over 2. See any simplifications to make?
The 2's cancel.
These will cancel. And I'll put the negative in the numerator. Negative square root of 2 plus the square root of 2 over square root of 2 minus square root of 2. And I don't know, generally maybe you think, well, you should get that square root out of the denominator, so let's multiply and divide both sides by the square root of 2 minus the square root of 2, but I think I'm going to stop there instead. Do you think we could do that, though, for any angle theta? Yeah. So let's do that. If you want to compute the tangent of theta over 2, it's the sine divided by the cosine, so it'll be plus or minus the square root of 1 minus the cosine of theta divided by 2 divided by plus or minus square root of 1 plus the cosine of theta all over 2. Just by looking at that formula, do you see any simplifications?
The 2's.
The 2's cancel. And I don't know if the numerator is positive or negative. I don't know if the denominator is positive or negative. So do I know if tangent is positive or negative?
No.
No. So there's no hope. There's just going to be a plus or minus. Maybe we can rewrite it using a single square root, though. So there's the half-angle formula for tangent. The tangent of theta over 2 is plus or minus the square root of 1 plus the cosine of theta divided by 1 minus sine over cosine, Chris. 1 minus the cosine of theta divided by 1 plus the cosine of theta. People feel pretty good? So let me go ahead and allude to what's on the next page, which I think I'll treat as an extra credit. So you could use the half-angle formula to figure out what trig functions are at pi over 8. Once you know sine and cosine at pi over 8, you think you can figure out sine and cosine at pi over 16?
Yeah.
And sine and cosine of pi over 42?
Sadly.
Pi over 64?
Yep.
Yeah. Yeah, so the formula for sine should just be like, the formula for tangent should just be the formula for sine divided by the formula for cosine, but then simplified.
Because you said that this was positive, all the way back to negative 5.
Ah, that's not 5 over 4, that's 5 over 8.
But when we solved for 5 pi over 8 for cosine, this was negative inside of here because it was cosine 5 pi over 4.
Yeah, so let's talk through it. So, this was for the sine of pi over 8. So there's the plus or minus, which I guess we decided was plus.
Yeah.
The square root, and sine is 1 minus the cosine of theta, so 5 pi over 4. All the way to 2.
So isn't that negative?
So it would be the square root of 1 minus negative root 2 over 2.
Okay.
So that does make sense why there should be a plus there. Hopefully there is a plus there.
There is, yeah, I have the plus here. So is it because cosine of 5 pi over 8 is negative, but sine of 5 pi over 8 is positive?
Yeah, so it's what really is the difference between that being a plus and that being a minus was because the cosine of 5 pi over 4 was negative.
But isn't the sine of 5 pi over 4 negative?
By magic, the formula for the sine of a half angle involves cosine.
Oh.
Yeah.
Okay. All right, that's weird. Okay, thank you.
Yeah, so I mean, right, so there's not a sine formula, but there are suggested formulas.
Right.
Which, I mean, whenever you see a complicated formula, even though presumably you're going to put that formula on your note sheet for the final, you need to practice using the formula.
Right.
So do as many examples as you have time to do today.
Okay, thank you very much.
Yeah.
And are we getting a review guide that will be similar to the test?